السلام عليكم شلونكم قوتابیان خوشحاڵم لەوانەیەکی نوێ هاتم وڵاتان ئەمڕۆ لەوانەیەکی نوێ دەست دەکەین بە خوێندنی چاپتەری دووەم the second chapter the acids and the bases. Let's dive into it. Okay, so chapter 2, it's about the acids and the bases. Section 1, as a first step, we'll start by studying some general properties of the acids and the bases, including their relation with our daily life. Then we will go farther until we'll include them into some reactions in terms of the acid-base reaction, and then the reaction between the active metal and the acids, and so on. So be careful in this chapter. Again, we will build up too many basic information, too many basic idea for the next chapter, mainly chapter 3, okay, and also chapter 6. Well, general properties of acids and bases. First of all, let's begin with our daily life. Most of the foods that we use daily are acidic. They are acidic. Example, you should memorize the following names. They're kind of important. Sometimes you will see them in Zhyar. يعني بەردەوامی پرسیاری لێ نایەتەوە بەڵام جار ها دەیگریدێتەوە. سو ئاگای لێبی ناتوانێ هیمالیکەی شتێک ئەگەر بێتەوە نەیخوێنی ڕێک دەکاتەوە لە وزاری. So be careful about that. Look. First of all, sour milk, also called yogurt, contains lactic acid. Yani must lactic acid. Juices, they contain vinegar, also called acetic acid, ethanoic acid, CH3, COOH. It's an organic acid, which is a weak acid, a monoprotic acid. Later, we'll take enough info about it. Lemon, orange juice, and grapefruit, they contain citric acid. In Kurdish commercially, we call this lemduzi, okay, citric acid. Apple contains malic acid. Apple contains what? Malic acid. Grape juice contains tartaric acid. Most importantly is the last one, which is the tart flavor in many carbonated beverages. So the carbonated beverages or fizzy drinks, they contain the following 3 acids. Also, they may contain something else, but most of them, they have the following acids in common. The first one, benzoic acid. The purpose is the preservation. Benzoic acid, sorry, this is a phosphoric, okay. Benzoic acid is used as preservative material. Benzoic acid. And then phosphoric acid, most importantly, the main reason to use phosphoric acid in the carbonated beverage is phosphoric acid used as flavoring agent. It provides a tart flavor, the acidic flavor, which is not toxic, and also carbonic acid. So, fizzy drinks contain how many acids? 3 acids. The first one, phosphoric acid for the sake of flavoring. Then, benzoic acid for the sake of keeping the things for a very long period of time as a preservative material. And then, carbonic acid. Look at this picture. It's in the book. This is a glass of Pepsi or Cola, I don't know. We have the following acids in this product. Look, benzoic acid and sorbic acid, they're both used for preservative. They use as preservative material. So they are preservative material. Also in chapter 10, we'll take the third one, which is the propanoic acid. So it's better for you if you memorize all the preservative materials right now. Benzoic acid, sorbic acid, and propanoic acid. These are 3 acids that are used as preservative material to kill the microorganism. Good. And then phosphoric acid for the sake of flavoring. lastly carbonic acid. This is lemon. Lemon contains ascorbic acid. This is ascorbic acid. Commercially, we call this vitamin C. Vitamin C. So ascorbic acid is the vitamin C. Be careful. Then citric acid, lem-2Z, we know this. Look at this. Fruits and juices contain acids. Fruits and juices contain acids such as citric acid and ascorbic acid. I say ascorbic acid is vitamin C. Good. Now it's time for the bases. Okay, you may ask, Mr. Now acids in our daily life are foods. Example, yogurt contains lactic acid and so on. Good. And we have some of them as preservative material like benzoic acid, sorbic acid, and the other one, which is the benzoic acid, sorbic acid, and propanoic acid. Good. But how about the bases? Are they foods again, or they must be used for something different? Well, bases, generally, we use them as cleansing agent for cleaning purpose. Look at this. Ammonia is household ammonia is an ammonia water solution. Ammonia water solution, it means NH4OH, ammonium hydroxide. Ammonium hydroxide. Hopefully you understand my handwriting, which is the most wonderful handwriting in this room right now, because only I'm here. I'm alone here, that's right. Good. So household ammonia is the ammonia water solution that is useful for all types of general cleaning. Also, sodium hydroxide, NaOH, known by the common name lye, is present in some common commercial cleaners. Good. So now bases are used as cleansing agent for general cleaning purposes. Okay, we have something else. Look at this. This is the most important part of this page. Look, milk of magnesia, which is called Mg, the formula MgOH by 2, magnesium hydroxide, also milk of magnesia, they are the same, magnesium hydroxide. This is also called milk of magnesia. Is a suspension in water. Just read this, it's nothing. But let's have the most important points about this section. MgOH by 2, AlOH by 3, and NaHCO3. Sodium bicarbonate. NaHCO3. Great. Look, never forget the following formulas. MgOH by 2, AlOH by 3, and NaHCO3. They look like bases. But the point is, what is the purpose of using them? Look, they are called anti-acid or antacid. So these are anti-acids. Be careful. They use to destroy the excess stomach acid, which is HCl. Example, stomach releases HCl that aids the digestion process. In case of releasing extra HCl, you're going to feel discomfort. You feel, stomach burning. In this case, we will take a syrup that contains the following substances, which are called anti-acid or antacid. Then we will relieve the discomfort. Very good. How many anti-acids do we have? So now tell me, please. Okay, mister, we have 3 anti-acids. The first one, MgOH by 2, magnesium hydroxide, which is also called milk of magnesia. And then AlOH by 3, aluminum hydroxide. Lastly, NaHCO3, sodium bicarbonate or sodium hydrogen carbonate. Let's begin with the acids. First, We have studied the general properties of acids and bases based on our daily life. Acids are used as foods, bases are used for cleaning. Some of them used as anti-acid, as a medication. But now, let's read the scientific properties of acids based on the lab data. I mean laboratory data, experimentation. The first one, aqueous solution of acids have a sour taste. They taste acidic, sour, but not by direct tasting, because some acids are toxic, poisonous, and they destroy the body tissues. It's impossible to taste the acids directly. Be careful. Secondly, acids change the color of acid-base indicator. Acid-base indicator, also called pH paper. pH paper or acid-base indicator. The color of this paper in acidic turns to red. Turns to what? Red. Well, let's repeat the two properties of the acids. The first one, they taste sour, acidic. Okay, but it's by direct tasting or by something like experimentation. Of course, by experimentation. It's impossible to touch or to taste chemicals directly. It's impossible, my dear, because some of them are toxic, poisonous. They destroy, they burn the body tissues. It's impossible to touch them. Then they change the color of acid-base indicator. To what? To red. To what? To red. So what is the color of the acid-base indicator in acidic medium? Oh, red. Red. يعني acid عملنا خوبا بي دالين ترش بكردي acid دالين سي ترش لهوليري نورمال يا ما ترش لهوليري أنا زور لهوليري جينا دزانا لما على بكسر شيء جوري تامبلي ها برنزو مرقة هيا وزا أما زور زابا مرقة دالين ترشو مرقة ترشو برنز بابلين بقولها ترشو برنز مان هيا دالي ها ترشو برنز ترش رنجي تونا نورمالي رنجي سورة. So the color of acid-base indicator in acid, the color of acid-base indicator in acidic medium must be red. ترشو برنز معناه ترش رنجي كو نورمالي سورة. أصلاً ما ببروفيسور وشي أو طلبة بكي وتي ما مساعدي أجر ترشكه هي كديبو يعني هي قيسيبو خسرني زرد. المهم هو يبزانه يعني ترش سورة رنجي. I mean the indicator inside of the acid is red. The third point, some acids reacted with active metal. Look at this. Something really important. Acids reacted with active metal to release hydrogen gas and producing salt. Just like this. Active metal plus acid. Okay, what are the active metals? Normally in this book, we will use the following active metals like Zn, Al, group 1 elements, lithium, sodium, potassium, rubidium, cesium. Group 2 elements also. Plus acid to release hydrogen gas and salt. The salt can be solid or aqueous based on the rules. If you remember, rules for solubility and precipitation in chapter 1, we have a bunch of rules, if you remember. Okay, later we'll get back to this by the end of the chapter. Let's repeat all the points. The first one, acids they taste sour. The second one, they change acid-base indicator. The color is red for the indicator inside of the acidic medium, and then acids react with the active metal to release what? What is this? Hydrogen gas and what? Salt. According to this, I don't talk about the following reactions for now. Later, by the end of the chapter, we'll get back to this with a bunch of examples. The fourth point, acids reacted with bases. Okay. Acids reacted with bases to produce salts and water. This reaction is called neutralization reaction. Write this name, important. What? Neutralization reaction. Neutralization reaction. What is the neutralization reaction? Acid plus base. What is the name of the reaction between the acid and the base? Neutralization reaction. Acid plus base is called what? Neutralization reaction. This is called neutralization reaction to form salt and H2O. To form what? Salt and H2O. So how to obtain salt and H2O together alone? As the we can have them as the result of the reaction between the acid and the base together, which is called neutralization reaction. Great. But there's a point. Think about this acid. It has a sour taste. It will change the color of acid-base indicator to red. It can react with active metal to release hydrogen gas. But when it reacts with a base, it will lose the following properties. They cannot taste sour anymore. They cannot react with the active metal anymore. Or the ability to change the color of the acid-base indicator will be changing. So be careful, please. How many properties will be disappeared? 3. The taste, the color, the reaction with the active metal. For what? For the acid after reacting with the base. After reacting with what? Base. Look, acid man here, say property خوی here. بلام دوای ئەوەی لەگە بەسێ ڕیاک دەکا و بەسێ ناوی ئافرەتانە دەزانی دوای لەگە بەسێ یەک دەگری تر ها بە کاملی دەگۆڕێت تەبیعەت چی تێدەچی ڕەوشتی هیچ نامینێت چکە ها لەگە ژنان تێکەڵ بووە لەگە بەسێ تێکەڵاو بووە ئیتر ڕەوشتەکانشی هیچ نەمایە دڵتان گەورە بێ قسانە بە تەبیعی بگرێت. Okay. As I said, I don't talk about the following examples. By the end of the chapter, we'll take them alone in a specific lesson. Okay. So now acids, aqueous solution or aqueous solution of acids conduct electric current because all of them are electrolyte. Some of them are strong. Some of them are weak. The one that is strong, they ionize completely. The one that is weak, they ionize what? Partially, slightly. Great. Keep going. It's time for the classification of the acids. I should take a sip of coffee. Look at this. Acids nomenclature. First, let's classify the acids based on their formula or the number of atoms. Look, we have 2 types of the acids, oxyacid and binary acid. Oxyacid and binary acid. You should know the following facts about the binary acids. First of all, they contain of 2 different atoms. 2 what? I didn't say 2 atoms. I said 2 different atoms. Then, one is always hydrogen and the other one is X. What is X? A highly electronegative atom. More electronegative atom. What are the more electronegative atoms? Look, chlorine, fluorine, bromine, and iodine. These are the more electronegative atoms. It means the combination of them with hydrogen results the binary acids. The binary acids. So the binary acids are HCl, HF. Also, we have sulfur here. HF, HI, HBr, and the H2S. These are the only 5 binary acids. We have only 5 binary acids. Look at their structures. There is no oxygen. So they don't have any oxygen. No oxygen. The most 3 important facts about the binary acids. First of all, they contain 2 different atoms. Secondly, one is hydrogen, the other one is more electronegative atom. What are the more electronegative atoms? sulfur, ClBrIf. Then, is there any oxygen? No, they don't have any oxygen. And they are inorganic because they don't have any carbon. Later in chapter 10, you learn this. Wait for this. Let's keep going with the binary acids. Look, naming of binary acids. Naming of binary acids is carried out according to this rule. This is really important. I've seen this I think it was 2022-23 first term. Yeah. أول وزاريات بوا بالضبط صار كم نبيت معه بس دخولية كمان بوا. So how to name the binary acids? The prefix of hydro plus root of the name of non-metal plus IC plus acid. Let me tell you something. Between the oxygen and hydro, we only use one of them. If we have oxygen, then we don't use hydro. But if we don't have oxygen, then you should use hydro. Be careful. Now, binary acids, are they contain oxygen? No. They don't have any oxygen, so you should use hydro. But if they contain oxygen, we don't use hydro. Now there's no oxygen, we have to use hydro. How to name this? Hydro plus root of the name of non-metal. Hydrofluor, this is the root. Hydrofluor plus IC fluoric acid. HCl, hydrochloric acid. HBr, hydrobromic acid. HI, hydroiodic acid. H2S, hydrosulfuric acid. If you remember, for them, it's okay to have them as their gaseous state or aqueous state. In case of their aqueous, we will use this. But if they are gases, we will use the system of hydrogen halide. Example, gaseous HCl is called hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen sulfide. But now, because I say they are acids, so they must behave like an acid in the aqueous solutions. That's why we assume that they are aqueous. Great. Okay, let's repeat all the steps from the first. Binary acids, they don't contain any oxygen. They contain only two different atoms, one which is always hydrogen, the other one. We have 5 different atoms which are more electronegative atoms, okay? Hydrogen with sulfur, H2S, HF, HBr, HI, HCl. Their name must start by what? By hydro, must end by IC. Good. Another important point, if I tell you how to take out, how to get, how to prepare an anion from the acid, how to get anion from the acid just by removing the H atom. Remove what? The H atom. Look, if I remove this H, it contains 1 hydrogen, so the anion must be -1. Remove this, Cl -1. Remove this one, Br -1, I -1. We have 2 hydrogens. Remove both hydrogens, S must hold -2 charge. If I remove 3 hydrogens, it must be -3. Good? As you can see them here, how to change the name, or what will be the name of the anion. So this is name of anion. Look, as I said, if they are gas, it will be like this. Look, if I convert acidic molecule into the anion, so what to do with the name? First one, remove the prefix of hydro, then remove the acid, then change IC into IDE. Look, fluoride. Remove this one, fluoride. Good. How about this one? If I remove, this is HCl. Remove hydrogen for the sake of anion. So how to change the name? Okay. Remove the prefix of hydro with the suffix of acid. Change IC into IDE. Chloride, bromide, iodide, and the sulfide. mister. So if we have an anion with the prefix of IDE, that means it has been originated from something that ended by IC. But what kind of IC? Binary acid. What? Binary acid. Binary acid. Look. Wait for this. It's time for the second type of the acid, which is the oxyacid. Let's get back to previous page. Not this one, please. Okay, oxyacids. Also called sometimes, it's okay to say tertiary acid. It means cyani. Binary yani duani. Oxyacids, they contain 3 different atoms. The first one is hydrogen, mostly. The last one is oxygen, mostly. In the middle, we have non-metal most of the times. Non-metal, okay. So oxyacids contain 3 different atoms, unlike binary acids, in which they have 2 different atoms. But here, 3 different atoms. The first one is hydrogen mostly. Generally, I will say generally, because I know we have acetic acid, CH3COH, or the other acids. But when I say generally, it means I know the exceptions. Be careful. Hydrogen, oxygen by the end. In the middle, we have non-metal most of the times. Don't say always, because we have some acid that contains metal, but it's not in the book, like chromic acid, H2CrO4 or H2Cr2O7, dichromic acid. Another thing, are they contain oxygen? Mister, you say between the oxygen and hydro. If we have oxygen, we don't use hydro. But if we don't have oxygen, we should use hydro. Okay? So now we have oxygen. We don't need hydro. The names. It's impossible to use hydro for the oxyacids. Let's get into it. Oxyacids nomenclature. Look, I will explain this, don't worry. H2SO4, it's sulfuric acid. Why don't you say hydrosulfuric acid? Mister, ادي اكسجين سرخري نابيني ليره بابي من كل اكسجين تي هيدرو بكارنيني اقدر حيامان نبي sulfuric acid is H2SO4. Decrease this by 1 oxygen to form H2SO3 will become sulfurose. So if I remove 1 oxygen, IC must be added to OUS. Mister, it means if we have 2 acids and they contain only 1 difference between them, and the difference is only 1 oxygen, it means if we have 2 acids, they're almost the same. The only difference between them is only 1 oxygen. In this case, the one with more oxygen must end by IC. The one with less oxygen must end by OUS. I'll repeat this in Kurdish. دوای حەزم لێ بوو بە فارسیش دێنێت تەماشا ئەگەر 2 ئاسیدمان هەبوو تقریبا هەموو سەرشکلیان وەکو یەک بوو تاکە جیاوازی لە بینیان 1 ئۆکسیجین بوو چەند ئۆکسیجین بوو 1 ئۆکسیجین دەڵێ ئەوەی کەوا ئۆکسیجینی زۆرە بەچی ئێن دەبی IC ئەوەی ئۆکسیجینی کەمە بەچی OUS. But this is not always true. Be careful. Be careful. This is not always true. Let's see. H2SO4 sulfuric acid and this one sulfurous acid. Selenic acid, decrease 1 oxygen, selenose. Phosphoric, phosphorose. Nitric, nitrose. Or nitric, nitrose, no problem. The point is, binary acids, they end by IC, their anion must end by IDE. This is the name, this is the anion. But for the, this is for the, okay, binary. But how about the oxyacids? We have 2 different suffixes. Some of them, they end by IC, some of them by OUS. So how about the anion? The one that ended by IC must be turned into ATE, okay? IC8, E8, IC8, okay? IC turned into ATE. And the one with OUS turn it into ITE. OUS, turn it into ITE. Look at this. How to form, how to create, how to take out the anion of the acid. Just remove the hydrogens. What left? SO4. Because I have removed 2 hydrogens, so it must be SO4 negative 2. SO4 negative 2. Good. How about the name? This is sulfuric acid. Remove the term of acid. We don't have any prefix of hydro, so leave it. IC must be turned into ITE, sulfate. Don't say sulfurate. This is sulfate. This one, sulfite. Say it. HNO3 is nitric acid. Remove this hydrogen. What left? NO3 negative 1. This is negative 1 for the sake of removing only 1 hydrogen. Then remove acid, turn IC into ATE, nitrate. And HNO2, remove this hydrogen, nitrous, change OUS into ITE, nitrite. Bromic, bromate. بەو شێوازەی دەتوانێت ئەتوو ئانایۆنەکان وەرگری زۆر بە ئاسانی ئاسانشتش زەحمەت نییە شەبابم you don't need this part, it's nothing, or you can remove it. So let's name the following acids. بەجددی ئەو شتێکی گەلە نازدارە لەگەڵم بە قوتابیان باوەڕ هەبی ئەوە یەک لە تەکنیکە هەرە جوانەکانە how to name any acid. But in order to do this, you need to know list of the ions. You have to memorize the ions. Not you have to. It must be memorized already. The chapter یەکەم زۆر ئاگادار کردیەوە بۆ دەبێت ئایۆنەکانت هەر لەبەر بی. ئەو جەوابەی ئایۆنەکان ئەتو ناتوانی لەو تێبڵێتی بکەی. ئایۆنەکانیش ئێستا بە تەڵەبەی پۆلی دەی بڵێم لەبەریان کردیە. بە تەڵەبەی پۆلی یازدەی بڵێم لەبەریان کردیە. جەنابیشت لە دیار ئەو ڤیدیۆی دانیشتی دەبی ئایۆنەکانت لەبەری پۆلی دوازدەی. یعنی هەندێک شتەیە بەڕاستی دەتوانم بڵێم لە بۆ تەڵەبەی پۆلی دوازدەی شوورەیە تا ئێستا ئایۆنەکانی لەبەر نەبی. ئۆکێ یاتیادیە لەو دەقەیەوە هەوڵدە لەبەری بکە پلیز. باوەڕکە بەبێ ئایۆنەکان لە چاپتەری دووەم بەجی دەبینی. کورە لە چاپتەری سێم بەجی دەبینی. لە چاپتەری شەشەم ڕێک دەزانیت بەسە دێ دەبێ فلیمی جۆن ویکی. خۆت عاقڵ بەتکە بە جوانی جێ بدەیت. Look at this. How to name the following acids. Example. We have this acid. How to name this? First, take the anion. ClO3. ClO3. Okay, I'll write ClO3 below of it here. Only take the what? The anion. ClO3 negative. What is the name of this? Chlorate. What is this? Chlorate. Let's return back the name of the acid. First of all, how to get ATE? So the suffix must be IC. Chlorate must be chloric. Chlorate must be chloric acid. Okay? Do we need to use hydro? Yes. No. Yes. No. Oh, mister, we have oxygen. We don't need hydro. Good. Let's get to this. BrO3. What is BrO3? Bromate. Bromate. Ended by ATE. How to get ATE? From IC. So change ATE into IC. Bromic. Then acid. I will use hydro. No, please stop. This time, قابلة fair نبي باشهم بي. Oxygen man here. We don't need to use hydro. دورة أوش حال كوارع. HCl. What is Cl alone? In the list of the ions, Cl alone is chloride. Mr. Chloride. How to get IDE again from IC? So the beta C, chloric acid. But how about the hydro? Yeah, there's no oxygen. You should use hydrochloric. Take this one. Yalla. ClO2. What is ClO2? ClO2 is chloride. ITE, how to get ITE? From what? From OUS. Change ITE into OUS. Chlorose acid. Without hydro. Chlorose acid. This one. Let's solve this one. BRO. What is the name of this? Hypobromite. ITE must be turned into OUS. Hypobromose acid. Hypobromose acid without hydro. Very good. Of course for me, not for you. Another exercise which is really important. So from the following salts. Okay. تم شاق تابي عزيز تكات خود زون عقد دبي. أو يكلوف كراقيانة كدبي للاد. عقب بسيارة شلتو بك. What is salt? Salt here. والله مستر salt ده كاتايون وأناياني بيدي. عافية. أي أنايون لشيء دروس بوا. إيه أنايون لأسيدي هاتية. صون أنايون لأسيدي هاتية. Just remove the hydrogens, you'll get the anion. Done. Okay? So now, let's answer the following questions. Calcium oxalate. This is calcium oxalate. CaC2O4. The anion is oxalate. Oh, what is happening here? My God. Be patient until I remove this. Great. Calcium oxalate, CaC2O4. The anion is The anion is C2O4. C2O4. The charge is negative 2. How do we know this? Babi من تخواب سياري لو ذكي. إنهم قد بي أيون الدبر بي. أيون ما نلبر كرباشة مستر. That's what. Stop. Tell me what will be the acid. Because it's a negatively charged to ion, so that means 2 hydrogens are removed previously. It's H2C2O4. How about the name? Oxalate. This is oxalate, right? Oxalate. ATE must be turned into IC. The beta? Oxalic acid. Oxalic acid. Just like this. Look. Another one, nitrate, potassium nitrate. This is KNO3. The anion is NO3, negative 1, which is nitrate. What will be the formula of the acid? Because we have 1 negative per this ion, so 1 hydrogen is removed. Has been removed, I mean. So it will be HNO3. The name is ATE must be turned into IC, nitric acid. How about the hydro? No, we don't need hydro. There's oxygen. Great. Another question. Look at this. For the glacial acetic acid or glacial acetic acid, the term of glacial, it means something like crystal of ice, crystal buffry. Crystal of ice. Crystal of ice. Glacial acetic acid cannot conduct electricity, but after dissolves in water, it can conduct electricity. Because, glacial acetic acid, CH3COOH, it's a pure form. It can be solid or liquid. So this is glacial acetic acid. Because, without water, it cannot ionize. In chapter 2, I have said everything about the ionization formation of ion by the action of solvent. There's no solvent, so we don't get any ion. There will be no electricity conductance. That's why it cannot conduct electricity. So glacial acetic acid cannot conduct electricity. Why? Because it cannot ionize. Not ionization. not ionize it. So if it's not ionized, there is no ion. No ion. Okay? That's why it cannot conduct electricity. But after being dissolved, it will ionize to release the ions. Then it can conduct electric current. درسی دا به low page او دست پیدا کن. 5 most common industrial commercial acids. We'll take one per any lesson. But the آنها گرینگن زور بیزارم بسیاری لیده تو سالانه. راسته ئەوزانی چی پێدەڵێن ئەو پێدەڵێن ئەدەبی کیمیایی ئەدەبی کێمستری وەکو ئەدەبی کوردیە شاعیرەکانە بەڵی دەکەوێت ئەدەبی کێمستری بەڵام however it's something like a theoretical without any rules, so I will explain all of them. I will simplify them, don't worry. I'll give you the most important notes points about them. Inshallah توانید بخواتان دەست بێرم بخواتان لەگەڵ بخوێنین عاقل